Welcome to the Developer Service YouTube channel. On today's episode, we're going to be crafting our own ChatGPT with ChainLit and MistralAI. So we're pretty much going to build a Mistral GPT. We can see it running. Let's ask, how is the sun? And we can also change to a different model. The most recent one, 22B. What is the sun? Join me in this episode to see how we can build this Mistral GPT with MistralAI and ChainLit. As usual, we are going to be basing this video on the developer service blog post, crafting around ChatGPT with ChainLit and MistralAI. I will leave a link in the description for the blog post and also how you can get the source code. So let's see now how to implement our Mistral GPT. Before we start, since we are going to use MistralAI, you need to have an account with MistralAI and also creating an API key if you have not an API key available. So you go to mistral.ai. You can either sign up if you're not signed up. In my case, that I'm already logged in, and you'll arrive at your console and dashboard, and you're going to need to create a new API key. I'm going to create a new key here, which I will delete after showing you the code. So this key name, I'm going to call it Mistral GPT, so that just we know. I'm going to create this key, and I'm going to copy the key. Make sure to copy the key because this will be the only time that you're going to see this key, and that's the first initial step that you need to do. So as you can see, I have a project open in Python. We have our requirements file, our .env to place the API key, and our main file, which we will run with ChainLit for the ChainLit application and the Mistral GPT. Let's see in terms of requirements. We have, of course, ChainLit, MistralAI, and we're using Python decouple, so we can use the environmental variables. So our .env file, of course, we are going to be filling in the Mistral API key with the key that we copied before. Let's paste here now. I will revoke this key afterwards, so there's no problem that I'm showing here. So let's see now our main.py file, and let's see what code we need to implement our Mistral GPT. So obviously we have the imports. We are importing ChainLit and several components from ChainLit. We're importing the config from the Python decouple, and of course for MistralAI we're importing the Mistral client and also the chat message, so we can provide also a system message to the Mistral GPT. In terms of the ChainLit application, there is two necessary methods that are needed, that are decorated with the ChainLit decorators. So there always needs to be an on-chat start, which happens when we create a new chat on ChainLit, and a non-message, which happens when the user types in a message and press enter. So this will be the method that's going to be called. We are also in this case filling in an optional method, which is the onset settings update, because we want to provide the possibility to choose between different type of models from the Mistral AI. So let's now see the code that we are going to need for our on-chat start. So initially we are going to be setting up our Mistral API and our Mistral client. So we are loading the API key from the config, from the .env file. We're setting up the initial model, which in this case is going to be the Mistral Small, the latest version. We're instantiating our client with that API key, and we're also defining in a variable the system message that we're going to pass to the Mistral GPT, stating it's a helpful chatbot and it will help people with answers to their questions. Afterwards, we store a couple of variables in session, in the ChainLit session, so that we can retrieve it later on the chat message reply. So we're setting the Mistral client, so we're setting the instance of the client to this session variable. We're also setting the system message and also the model, so that we can now retrieve this later on the message reply method. Additionally, we are setting up an initial set message, which is a welcome message, welcome to the Mistral GPT, and the other is going to be the Mistral GPT, and of course we are sending that message. We are instantiating a list for keeping the message history, because of course we need to implement some sort of history so that it works as a chat, and the Mistral AI has access to the chat and it can reply based on the contents also of previous conversations. As before, we're passing in that message history to the session through this variable. we're defining a settings component, which will allow us to basically a combo box that will allow us to select between different models. In this case, the Mistral Mixer of Expert 7B, and also the Mixer of Expert 22B. And we're setting the initial value to be the 7B, and the description to be the selector model that you want. And we're sending that to ChainLit to set up the initial settings with this command. So next, we need to handle what happens from when in the settings, which from the combo box, we choose a different model. So we're getting in that we define that in this setup agent, which is decorated with the on settings update, and receives the settings that have been selected by the user. So from those settings, we are retrieving the selected model. We are setting that model to the ChainLit session again in the model variable. And we are sending a message to the chat just to confirm that the model has been changed. And we say that the model has been set to that model, which of course the author of that message is ChatGPT. And we are sending that message. So basically the important part here is that we are starting the model in session, which might be different than the model that we started when we initialized the chat. Now we're going to see the method that replies to the messages from the user, and we are in this function on message that is decorated by the on message from ChainLit. Of course, initially we need to get all the variables from the ChainLit session. We have the client, the system message, and also the model. We're getting the user message from the content of the message. Message is the variable that it's passed on by ChainLit when replying to this message. So we have the content of the message that the user has written. We are doing a little trick here, because we are sending in an empty message so that it displays the loading while we are calling the API. Next, we're creating our template for the message history. So we're retrieving the message history from the session. This will be returning a list. We're creating our prompt template, and we're passing on that in terms of what was the previous messages. And for each message in the message history list, we are appending to that prompt template the message author, which is going to be either the human or the AI, and we're also passing that message content. And we're finalizing the prompt template by passing the user message that the user has typed as a human. Next, we're prepared to invoke the Mistral chat. So we'll define the list of messages that we're going to send to the Mistral AI API. So we have our system message, and we also have our user message, which is the prompt template that we just defined before, and that includes the message histories, but also the most recent message that was typed by the human. We are calling the Mistral API with the chat stream. We're passing in the model that we have retrieved also from the session variable. We're passing in the list of messages, and this will return or stream a chunk, and we are checking if it's an end token or if it's an empty token, and if that's not the case, so for each of the chunks that are being returned, we're streaming that as a ChainLit message that performs the stream as we would normally see in any of the GPTs. And when that stream is finished, we just send the message to finalize in terms of the ChainLit the message sent. And after that, we add this message to not just the message from the user, but also the reply to the AI. We add that to the message history. So we append from author human, which is the message that the user just written. And with author AI, we're just appending the message that was just written by the AI when we call the API. And of course, we're again setting this message history into the user session. Okay, that is all the code that we needed to implement. Let's now see our Mistral GPT in action. So we can run that with ChainLit run in the name of the file, and in our case the main.py. And ChainLit is going to run. It will automatically open the browser localhost 800. So as you can see, the initial welcome message, also the model that has been set to that. We can change the model to the 8.7b or to the 8.22. Let's start with the 8.7b. And let's go to type a message. What is the distance from Earth to the Sun? And you can see the Mistral GPT replies quite fast, the API. Now you also see the streaming of the message. As mentioned, we can change to a more elaborate model. Let's try the 22B. And for this one, you want to ask what is the sum. As you can see, also quite a fast reply. And let's test the memory to see that is working. So let's start a new chat. And I'm going to say, my name is Nono. And ChatGPT welcomes me. Let's see if it remembers my name. What is my name? And as you can see, that's why you're passing the history. That MistralAI is replying based on our previous conversation. My name is Nono, and it's welcome me again. So as you can see, that is the memory working in action. And that is it, that we need to implement our Mistral GPT using the MistralAI and ChainLit. Just a final note in terms of the usage. So as you can see, we are using, here you can see that I've used a different model, but we are using for this Mistral GPT, we are using the Mistral 22B, and we're also using the Mistral 7B. You can see, despite that I've used quite some other models, not excessively, but I've used so far in this API 109,000 tokens. But if I show the consumption in euros, you see just these little chats that we have with the Mistral 8, 7 and the 22. I'm only at 7 cents. So quite cheap to run the Mistral AI, and it's also a good experiment to try to create a Mistral GPT. So thank you for watching. Like if you like this video, and if you like this type of AI content, subscribe for more content about Python, Django and AI. And until next time, happy coding!